Swayam Prabha. Digital India. Educated India.
Welcome friends, welcome to the course Introduction to Sampling Theory. So now from this lecture we are going to begin with a new topic, that is cluster sampling. Now the first question comes, what is a cluster sampling and under what type of circumstances this type of sampling can be used? And as the name suggests, clusters means the group of observations. So what are these clusters, why they are made, how they are made? And if you try to recall, I had talked about this cluster sampling when I was doing the stratified sampling. Although I had not told you the details, but I had discussed the topic that when the population of units is going to be divided into different subgroups, then we had constructed the strata. How? Such that they are within homogeneous and between heterogeneous. So when I was trying to discuss this question, at that time I had told you that in case if you try to make this strata just in an opposite way, the strata are within homogeneous and between heterogeneous. But if you try to make it within heterogeneous and between homogeneous, then that will be the case of cluster sampling. So now, means if I try to say, what is this cluster sampling? Have you ever observed this phenomena of cluster sampling in your life? I am sure that most of you must have gone to buy some vegetables or fruits in the market. Sometimes you can see that these fruits or markets, fruits in the market, they are sold in heaps. For example, means if you try to see in the fruit market or in the vegetable market, different fruits and different vegetables, they are sold in different ways. One simple option is by weight, that you say, okay, some potato is 20 rupees a kilo and so on, and whatever you want, half a kg, quarter a kg, that you can take. Second option is you can take by counts. For example, say banana and oranges at many places, they are sold in counts, that you take 1 dozen, 2 dozen or 3, 4, 5, whatever you want, you can take it. And there is third option also, which you might have observed, that what the shopkeeper will do, they will try to create the heaps. Suppose if there are oranges, so they will try to create the heaps of say 5 oranges, 10 oranges, 20 oranges, whatever they want. Now, what is the difference between buying the heaps, means some vegetable or fruit which is being sold in the form of heaps, or by weight? By weight, you can always have what you want. You can have 100 grams, 500 grams, 1 kg, 2 kg, 5 kg, whatever you want. But when you are talking in terms of heap, you have only one option, that you have to take the entire heap. You cannot pick and choose from different heaps. So now if you try to see this process, what is this process? That fruit seller or vegetables seller, they have created the heaps of fruits or vegetables, say oranges. Suppose the fruit seller has 100 oranges to sell, and the fruit seller has created suppose 5 heaps, each of size 20. Now, whenever the customer comes there, the customer is not given the choice to take only 5, 10 or say 12 oranges from a heap. He has only one option. He has to take the entire heap. So that means he has no option to take any 1, 2, 3, 4 up to 19 oranges, but the person has to take only all the 20 oranges. Now, in this case what will happen? The person will try to choose a heap or more than one heap depending on the need and requirement. So suppose if the person wants suppose 40 oranges, so that means the person has to take 2 heaps. Now there are 5 heaps, and out of those 5 heaps the customer chooses only 2 heaps. Have you ever observed that how the heaps are chosen and what is this entire process? So whatever are the oranges in those 2 heaps, they will become sold to the customer. Now, first of all, if you try to observe this process, what is happening? The fruit seller had 100 oranges. Suppose this is my population. So the fruit seller has a population of size 100, where the sampling units are the oranges. One sampling unit means 1 orange. Now, the fruit seller has converted those 100 oranges into 5 groups, 5 heaps. Yes, there can be an option, that means those heaps can be of equal size or unequal size, but at this moment, in order to explain you the concept, I am trying to take a simpler version that all the heaps are of the same size. So don't get confused on those things, right? So suppose we assume that the shopkeeper has constructed 5 heaps, and each of the heap is of size 20. That means there are 20 oranges in every heap. Now a customer comes, and the customer wants to buy 2 heaps, or the customer wants to buy 40 oranges. That means the customer has to buy 2 heaps, and then the customer tries to choose 2 heaps out of those 5 heaps. And now that customer has got 40 oranges in the bag. His or now his or her own oranges, right? So now if you try to analyze this whole process, what has been done? The shopkeeper had a population of size 100 oranges, which were converted into 5 groups, and then the customer comes, and the customer chooses a sample of size 2 heaps, and the customer takes both the heaps, and now there are 40 oranges with the customer, which are trying to, or which are actually creating a sample of 2 heaps or 40 oranges from a population of 100 oranges. So what we have done? The entire population was divided into different groups, different heaps, and then a sample of 2 heaps was chosen, and then whatever are the oranges in those 2 heaps, now they are the sample. They are the sampling units inside the sample. Actually, this is your cluster sampling. Now, those heaps or those groups which you have prepared, they are actually called as cluster. Now, yes, there are many questions which will now be cropping up, that how to create those clusters and how to choose the heaps, how to take the sample. Well, we are going to discuss all those things, but at this moment I wanted to make clear in your mind that what are we really going to do. Now, in case if I ask you, suppose you have to buy 2 heaps out of 5 heaps of those oranges, how do you choose them? Is it really possible that all the 5 heaps have exactly same sizes, same quality of the oranges? Or is it really possible for the fruit seller to create those heaps in such a way such that they are 100% identical? No. There will be some variability because oranges are the natural product, so they cannot have the 100% exact same size. Right. So, now think, what does the shopkeeper does and what you do? Shopkeeper wants to sell all the oranges. So, shopkeeper will try to create the heaps or the groups in such a way such that all the heaps are nearly identical. For example, if some oranges are not really of good quality, then the shopkeeper will ensure that the same amount of bad quality oranges should be present in all the 5 heaps. So, that means the shopkeeper is trying to create a sort of similar amount of variation in all the heaps. Remember, shopkeeper is not trying to prepare the heap such that a particular heap has smallest variation or the heaps are as homogeneous as possible. No. Because in case if the shopkeeper prepares the 5 heaps of the oranges in such a way such that 2 of the heaps contains all the good quality oranges and there are 3 heaps which are containing suppose some bad quality oranges also, then why the customer will buy those 3 heaps? The customer will buy only those 2 heaps, but that will be a loss to the shopkeeper or the fruit seller. So, fruit seller will try to create the heaps of those oranges such that every heap has got the similar amount of variation. And this variation is not going to be small. The fruit seller is not at all trying to make the heaps such that the variability among the oranges within the group should be very small. The person is trying to make all the heaps should to have the similar amount of variability. But within group variability, that means the variability among the oranges within the group, that is actually higher. And now, as a customer, what are we doing? We try to look into those 5 heaps and we try to judge with our own eyes that how much is the variation in the size, quality, color, etc. of those oranges. Although the shopkeeper has prepared all the heaps having the same amount of variability, but usually customers will have a choice and they will try to judge themselves that which of the 2 heaps are having the best oranges. Best means quality, color, they are good, they are big in sizes, etc. And then the customer is going to buy or to choose 2 out of 5 heaps. So customer is trying to choose 2 sampling units, and these sampling units are like that every sampling unit has some sampling unit inside it. Up to now, what was happening in the case of simple random sampling, stratified sampling, etc., my sampling unit was only 1 unit. Suppose if I say height of the student, so the height of a particular student or the student was my sampling unit. But now there is a group of oranges, group of students, that will become my sampling unit. So now the customer buys those 2 heaps of oranges, and now he puts both the heaps inside the bag. And now once those 2 heaps of 40 oranges are kept in the bag of the customer, do you think that he or she can really distinguish that which of the orange was belonging to which of the heap? No. So now this is the entire methodology, and these 40 oranges are going to create a sample of size 40. And don't you think that this looks like as if the customer has chosen 40 oranges from the population of size 100 oranges? Right. So now with this example, you can understand many things. First step, take the population. Second step, divide them into different groups. And when we are trying to create those groups, we have to keep some concepts over there. We have to implement some ideas over there, like as within homogeneous or within heterogeneous, between homogeneous or between heterogeneous. And then those groups are going to create my population units. Now we are trying to draw a sample, but we are trying to draw the sample as group of those sampling units. But we are treating those groups of sampling unit as one sampling unit, means every group is a sampling unit. And then we are trying to put all the oranges in the same bag. So now we have 2 heaps, but now we have 40 oranges. Well, in this case, we can use the simple random sampling also. And where the sampling scheme is going to be used? When you are trying to draw 2 heaps out of 5 heaps. And this is the basic difference between the simple random sampling and this cluster sampling methodology. If you try to understand the simple random sampling, then practically I am drawing 40 oranges from a population of 100 oranges. So I can choose any of the 40 oranges from the original population. That will be your simple random sampling. You can have with replacement or without replacement depending on your need and choice. But when you are trying to convert that population into different groups, that we are going to call as now clusters, and you are choosing the clusters in your sample, not the individual units which are inside the clusters. And then your sample will be consisting of a few number of clusters. Well, if you want, you can mix them together and that will give you the complete sample, but anyway, the sample consists of the cluster itself. So now, this is the cluster sampling, that when you are trying to convert the population into cluster and then you are trying to draw a sample of clusters and then you are trying to employ your estimation techniques on this sample of clusters, not on the individual units. That is a very important point, that here the estimation of the parameters, like in case if I want to estimate the population mean, then we have to consider the estimation on the clusters which have been sampled, not the individual units which are inside the clusters. And this methodology is called as cluster sampling. But there is a very interesting phenomena. The interesting phenomena is that if you try to see on one side your simple random sampling process and on other side your cluster sampling process, don't you feel that they are interconnected? Yes. And that is the thing, that is the important point which we are going to use to solve our mathematical algebra or to find various types of expression intelligently. Means if you can create a setup inside your mind that now your sampling units are not going to contain only one unit, but they are cluster of sampling units, then I promise you the type of algebra and the mathematical analysis and including the statistical analysis what we are doing here, that will become very simple to understand and very simple to implement. The only thing is this, you have to think in this particular way. And you will see that this entire lecture, as soon as I try to find out the estimators, bias, variances, etc., they will be based on this concept. And that is the reason I am trying to explain you here itself. The only thing is this, I have to tell you, how are you going to think? Once you can think, I am promising you this cluster sampling, the analysis or finding out the expressions in the cluster sampling becomes very simple, right? So now we begin with this cluster sampling. First I try to explain you, and then gradually we will try to develop different types of tools. And yes, as I said, these clusters can be constructed for equal number of units in every cluster or unequal number of units in every cluster. That means the cluster can be of equal size or say unequal size. So we are going to consider here both the cases, but definitely you know, intuitively also means you can think that when you are trying to consider the clusters of the same size, equal size, then definitely the algebra is become to be lighter. And when you are trying to construct the estimator for the unequal size cluster, then you have to think something more that we will try to discuss in this lecture. Right. So now let us begin this lecture, and I have uploaded the slides of this lecture on my home page. In case if you want to download these slides, you can go to my home page and you can download them in the PDF format. The address at which I have uploaded the slide is home.iitkn.ac.in/shalab/sp. And if you are facing any problem in reaching to this address, you can also scan this QR code using any free application from any cell phone, and you will come to the same address. And still if you are facing any problem, then I would suggest that you try to type my name and my institution name in any search engine on the internet, and I am sure that you will find my home page, and from there you can download these slides in the PDF format. Okay. So, now I come to the cluster sampling in a more formal way. Right. So, this is one of the basic assumptions in any sampling procedure that we have done up to now, that the population can be divided into finite number of distinct and identifiable units, which we have called as sampling units. And the smallest units into which the population can be divided are called as elements of the population. And the groups of such element, they are called as clusters. Now, you have understood what are these clusters. For example, the example which I took means every orange is an element, and the group of those oranges is a cluster. So, what really happens that in many practical situations, what happened that that the list of elements is not available. And if the list of elements is not available, you cannot construct your sampling frame as we used to do in the case of simple random sampling. And so, the use of an element as a sampling unit is not possible, it is not feasible. So, in such cases when it is not possible to create a list with the individual elements, then in those situations the method of cluster sampling or the area sampling can be used, and this helps us. Right. So, if you try to see what are we going to do in the cluster sampling, we have here a population that is going to be divided in different groups, and here we call those groups as clusters. So, suppose you have some units in the population, and those units are divided, some in cluster 1, some in cluster 2, and some in cluster, see here capital N. So, now here my population size is here N, right, and every cluster also has some number of units. Suppose if I say that each of the cluster has got capital M number of units. So, the total number of units in all these capital N number of clusters will become capital N into capital M, which is going to be the population size as Nm. Okay? Now what are we suggesting? That from this capital N clusters, try to draw here a sample, say by SRS. You can use WR, WOR, whatever you want, but usually we prefer here WOR because it is more efficient. So, from this capital N clusters, try to obtain say, a small n number of clusters, and I am calling them as say 1 to here small n. And this is the same concept. If you try to remember, we had a population of size y1, y2, y capital N of size capital N, and from there we had drawn the sample y1, y2, say yn, and at that time in the beginning itself I had discussed the difference between small y and capital Y, that small y does not necessarily mean that this is going to be capital Y1, but small y1 can be anything out of y1, y2, yn. Right. So, similarly the same concepts comes here also, that when I am saying that here this is my cluster number 1 in the sample, it does not mean that this is the same cluster. No, this can be any of the cluster out of the capital N number of clusters which have been created from the population. Right. So, that is where you have to be very careful in reading this slide, because I am writing here cluster 1 as well as I am writing here cluster 1. Well, I have not changed the color of the clusters also here and here, because we are going to take the entire cluster in my sample. Means if I had a sampling scheme where, for example, in the case of we were trying to draw a smaller number of units from the larger sample, then possibly I can indicate it by a different color. But here I have no choice except to use the same color or even the same size of circles also to denote the cluster. Right. Okay. So, this is about the cluster sampling, that entire population of capital NM units is now divided into capital N number of clusters, and each cluster is of suppose size capital M, and from this capital N number of clusters we are trying to draw here a sample of small n number of clusters. So, now tell me what will be your total sample size? That will be your n into capital M, because every cluster is of size capital M, right. So, this is the setup of cluster sampling. So, now I can say formally here that in the cluster sampling we try to divide the whole population into clusters according to some well defined rule. Yeah, what is this well defined rule? This actually pertains to a condition like within heterogeneous or within homogeneous or between heterogeneous or between homogeneous, but at this stage I will explain you the construction approach, that how are you going to do, whether you are going to take within homogeneous or within heterogeneous, and later on when I try to estimate the population parameter, then after obtaining the variance of the estimator, I will be in a position to explain you that why we are trying to take such a condition. This is the same thing what we have done in the case of stratified sampling also, right. So, now once you have divided the whole population into clusters according to some well defined rule, now you try to treat these clusters as sampling units. So, you can see here that in this picture these are my sampling units. Just like here, this is similar to here y1, this is similar to here y2, and this is similar to here yn. All this capital N number of clusters like your here capital Y1, capital Y2, capital Yn. Now, choose a sample of clusters according to some procedure. A procedure can be a simple random sampling or some other sampling scheme, and then carry out a complete enumeration of the selected clusters. This means here what? If you try to see from this picture here, that now you have got here cluster number 1, cluster number 2, cluster number small n, the total number of units in the sample is now small n into capital M. Now, this number of units have to be analyzed, and our statistical analysis is going to be based on all these units, right. So, this structure of this purple color, this is going to give us a sample, and this is your here population, right. Okay. So, that means you have to collect the information on all the sampling units which are available in the selected clusters. So, the entire cluster is going to constitute your sample, just like the customer had to adopt all the 20 oranges, whatever they are, good or bad, it does not make any difference. Heap is a heap, and the customer has no choice except to accept or not the complete heap. Well, this was about the methodology of the cluster sampling. Now, what happened that when you are trying to this cluster sampling, and particularly when you are trying to deal with the areas, so it is possible that all those areas may will become like a cluster. So, in case the entire area containing the population is subdivided into smaller area segments, and each element in the population is associated with one and only one such area segment, this procedure is called as area sampling. For example, you can take, suppose in some city there are different colonies. So, these are some different areas. So, the entire city is now divided into different colonies, and then every colony is just like a sampling unit, right. So, in such a case, this will be called as area sampling. For example, if you see in a city, the list of all the individual person who are staying in different houses may be very difficult to obtain, and even may not be available also, that how many people are staying in inside different houses. For example, if I say, suppose I take a city, suppose there are 5,000 houses. Now, if I ask you that can you create here a sampling frame of all the people who are staying in those 5,000 houses? Yes, practically I will say it is difficult. Yeah, it is not impossible, but it is difficult. On the other hand, if I ask you that instead of compiling the list of all the peoples who are staying in those 5,000 houses, can you also prepare a list of those houses? That is easier. For example, you might be knowing that every colony has, suppose, 100 houses. So, colony number 1 will have 100 houses, colony number 2 will have 100 houses, and so on. Well, in case if the colonies have different houses, but at least you know that colony 1 has 20 houses and colony 2 has 100 houses. So, what do you think? Which is easier job, to prepare the list of the houses or to prepare the list of the individual persons who are staying in those houses? So, obviously, preparing the list of houses is easier. So, in this case, what will happen? Every person who is staying inside the house, in a house, that person is going to be treated as a sampling unit. And every house, there will usually be, or it is expected, that every house will have more than one person staying there. So, all those persons who are staying in that houses, they will create a cluster, right? And then what are we going to do? We are going to select those houses in my sample, and that is going to create a condition where we are trying to choose the clusters directly. Clusters are our houses. Similarly, the list of agricultural farms in a village or in a district may not be easily available, but the list of villages or district is easily available. For example, if you try to go to a state and there you want to study the crop production, so that means you have to go to all the fields and then you have to see, but the list of all the fields or the farms where the crop is being grown up may be difficult to know, but definitely the list of villages or list of districts, they are usually easily available. So, that village or district, they are going to create the clusters, and all those agriculture farms which are in a particular district or in a particular village, they are going to create the clusters. So, we will try to select some villages or some districts, and whatsoever are the agriculture farms contained in those villages or district, they will be in my sample. So, in this case what will happen? Every agricultural farm is the sampling unit and every village or every district is the cluster. So, you can see here now this cluster is a group of sampling units, right. And if you try to see in practice what is easier, getting the information on sampling units or getting the information on the clusters. So, getting the information on the cluster is easier, faster, cheaper and convenient, and the information from them that can be collected easily rather than collecting the information on the individual sampling units. So, in these two examples which I have just taken, what we try to do? We try to draw a sample of clusters from the houses or say village or districts, and then we collect the observations which are contained inside those clusters, and we collect the observations on all the sampling units which are contained in those clusters or which are available inside those villages, cities, houses, etc. Right. So, the next question comes that under what type of condition this cluster sampling is preferred or more useful. So, this cluster sampling is preferred when no reliable listing of elements is available and it is expensive to prepare it also, or it may take a very long time to prepare those things. And in case, even if the list of elements is available, the location or the identification of the individual units may be very difficult. For example, I mean, suppose we know inside a house there are 5 persons staying, but getting the information on each of the 5 persons is more difficult. So what we try to do? We try to first choose the houses, and then we try to collect the information, the entire information on all the people who are staying in the house, in those houses which have been collected. Right. And one of the very important condition you have to keep in mind when you are trying to use this cluster sampling, that if you try to see here in this picture, this population will have different types of units, and these units have been divided into different clusters. Just like what we did in the case of stratified sampling also, but the condition or a necessary condition for the validity of the procedure that we are going to use in this cluster sampling is that every unit of the population under study must correspond to one and only one unit of the cluster, so that the total number of sampling units in the frame may cover all the units of the population under study, and without any omission or duplication. If you try to see that this is the same condition that we have used in the case of stratified sampling also, that every unit will belong to only one stratum. The same thing is here also, that every unit in the population should belong only to one cluster. It should not happen that a particular unit is be belonging to one or say more than one clusters actually. And in case if this condition is not satisfied, or if somebody takes by mistake some units which are overlapping or which belongs to more than one cluster, then the bias is introduced in the estimator that we are going to consider. Obviously, you are trying to give more information which is not needed. You are simply trying to repeat the information. Now, after understanding this methodology of cluster sampling, we have understood that we have to finally club our sampling units in different clusters. And particularly, when we are trying to work in real life, it may not be always possible that all the sampling units are located physically in a given boundary. For example, in the case of house, all the people who are staying in that house, they will be inside the house only, right? But on the other hand, in case if I try to see those agricultural farms which are trying to cultivate say wheat in a particular city or in a particular district or a particular village, then it may not be necessary that all the farms are clustered at one place and we can create a physical boundary. So based on that, we have the concept of open segment and closed segment. So when it is not necessary that all the elements associated with an area segment need be located physically within its boundary. Right? For example, as I discussed that when we are trying to study the forms, the different fields of the same form need not lie within the same area segment. And in such a case, we say that this is an open segment, that all the areas are not lying within the same area segment. But on the other hand, for example, in the case of house, that is a closed segment. So in a closed segment, the sum of all the characteristics under study, for example, this can be area, livestock, or the number of persons staying in the house, for all the elements associated with the segment will account for all the area, livestock, etc. within the segment. So that is the definition of the closed segment. And this is the main difference between open segment and closed segment. So this definition will be dependent on what type of sampling units you are going to choose, and how you are trying to create the clusters, and how is those sampling units are located in that area. Now, the next question comes, how are you going to construct the clusters? So that is exactly on the same line as we discussed in the case of stratified sampling, that the stratum have to be constructed in such a way such that they are within homogeneous and between heterogeneous. Similarly, now we have to think and decide how the clusters should be constructed. So at this moment, I am trying to explain you that how the construction take place, but when we are going to consider the estimator for the population mean and we try to find out the variance of that estimator, then I will be able to explain you statistically also that why the condition which I am going to explain you here will become valid. So these clusters are constructed such that the sampling units are heterogeneous within the clusters and homogeneous among the cluster. So if you try to see, this is just opposite to the stratified sampling, right? The clusters are constructed such that the sampling units are within heterogeneous and between homogeneous, right? So that's what I am writing here, that this is just opposite to the construction of the strata in the stratified sampling. So now, once now we have understood this thing, now we have to construct the clusters. So we have two options. First option is that all the clusters are of the same size, or all the clusters are of different sizes. So we will have two types of cases, equal size and unequal size clusters. First, we will try to take up the issue when we are trying to construct the clusters of equal size. We will try to develop the estimators for the population mean, and we will study its properties, and after that we will try to consider the case where the clusters are of unequal size, right. So we are going to discuss the estimation of population means and the variance of their estimators in both the cases. So first we try to consider the case of equal cluster. So suppose we have a population which is divided into capital N clusters, right. So I have marked it in red color so that you can identify here what is the change now. The change is, earlier we took the population of size capital N units, but now we are taking capital N clusters, and suppose the size of each of the cluster is capital M. So that means the total number of units in the population is going to be capital N clusters into capital M number of units. That is, the size of the population is capital NM, capital N into capital M. Now we are going to select a sample of size small N clusters. So once again I will say here, you have to keep in mind this is small n clusters, and this small n number of clusters are drawn by, say, simple random sampling without replacement from this capital N clusters. So the size of the final sample, that is the total sample size, will become a small number of clusters, and every cluster is of size capital M. So the total sample size becomes here small n into capital M. And now obviously when you are saying this, suppose y is the variable under study, so the observations on y, they have to be indicated by two subscripts. One for the cluster number, and second is the unit inside the cluster. So let small yij be the value of the characteristic under study for the value of the jth element. So j will go from 1 to capital M. These are the units within the clusters, and this is happening in the ith cluster. So there are capital N clusters, so I will go from 1 to capital N. And suppose I try to find out the mean of all the units inside the cluster. So, suppose I try to take the ith cluster here and I try to take here all the sampling units which are within the ith cluster, say yij, and I try to take the arithmetic mean of all those units. So, this will become 1 upon capital M summation j goes from 1 to capital M yij, and this is being indicated by y bar I. So, for example, if you have here 3 clusters in your sample, so whatever are your clusters here, all the units in the cluster 1, they will be denoted by y bar 1, mean all the arithmetic mean of all the sampling units in the cluster 1, their arithmetic mean will be y bar 1. All the sampling units in the cluster number 2, their arithmetic mean is going to be indicated by y bar 2, and all the units in the cluster number 3, their arithmetic mean will be denoted by y bar 3, and so on. And then this y1 bar, y2 bar, y bar 3, they are based on capital M number of unit. Okay, so now you can see here, this is the status of now the cluster sampling. Now we have here a population of size capital Nm units, and these Nm units have been divided into capital N clusters, and every cluster is of size capital M. So, we have cluster 1, cluster 2, say cluster number N, capital N. So, this is actually our population of capital N clusters. This is the population. Now, from here we are trying to draw a sample by say SRS, suppose WOR. So, we are trying to choose a small n number of clusters from this population. So, now we have here cluster 1, cluster 2, cluster number is small n, and every cluster is of size capital M units. Right. So, this is my here sample of a small n number of clusters. And remember one thing, I am using here the same simple, this is here cluster 1 and this is also here cluster 1, but it does not mean that this cluster is appearing here. This cluster 1 can be any of the cluster out of capital N clusters. You have to remember one thing. And this is the same thing which we have discussed, something like if my population units are y1, y2, suppose here capital Yn, and we are trying to draw here a sample y1, y2, yn. Okay. So, now what we are trying to do here, we collect a small n number of clusters from the capital N clusters by SRS WOR, and then whatsoever cluster we have obtained in the sample, we are trying to find the arithmetic mean of all the units in each of the clusters separately. So, based on this small n number of clusters, find the mean of each cluster separately, and this is going to be based on all the units in that cluster. So, now we have, suppose we have chosen small n clusters. So, we will have here sample mean of first cluster, sample mean of second cluster, and up to here the sample mean of small n cluster. But here sample mean does not mean that we are trying to choose the unit from the cluster. No, all the units are taken in the sample. So, this y1 bar is the mean of all the units in the cluster number 1, y bar 2 is the mean of all the units in the cluster number 2, and so on, right. And this is we are denoting by say y1 bar, y2 bar, y bar n. And now we have to construct here an estimator of the population mean. So, what we propose here, that we try to construct this estimator by taking the arithmetic mean of all the cluster means. So, this will become here 1 upon n summation I goes from 1 to n y bar I, right. So, you can see here it looks like a weighted arithmetic mean where the weights are given by 1 upon n, but I would try to show you here one thing here more. Now, try to recall about the simple random sampling. Y1, Y2 here we had the population this Yn, and from there I am trying to draw here a sample y1, y2, yn. And this population has a population mean capital Y bar, and this sample had a sample mean small y bar. Now I am replacing this y1, y2, yn as a y1 bar, y2 bar, yn bar, and then I am trying to find out here the mean of all these sample means. So now in case if I try to write down here, let z I be equal to say here y bar I. So since we are trying to draw the samples by simple random sampling, so we know that expected value of z I will be equal to population mean y bar. Now what is this y bar? For that each of the cluster will have a cluster mean. So I am writing here y1 bar, y2 bar, y capital N bar. So don't you think that it looks like as if we are trying to draw a simple random sample of small n means from a population of capital N number of means? Now you can establish a one-to-one connection between the cluster sampling and simple random sampling. Now this technique and this understanding is going to help us in finding out different types of properties like unbiasedness, variance of this estimator and so on, right. So now in case if I ask you to find out the sample mean of this, the expectation of this y bar cluster, which is here defined here like this one, y bar CL. So this will become here simply 1 upon n summation I goes from 1 to n expected value of y bar I, and since we are trying to draw the sample by simple random sampling, so expected value of y bar I will simply be capital Y bar, that we know from the simple random sampling concepts. Now if you try to take this sum, this becomes here n times y bar upon n, and this becomes here capital Y bar. So this y bar CL provides an unbiased estimator of the population mean, right. And similarly, in case if you want to find out the variance of this y bar CL, then this can also be derived using on the same lines as we have derived the variance of the sample mean in the case of SRS WOR. The only difference is that in SRS WOR the sampling units were earlier y1, y2, yn, now the sampling units are y1 bar, y2 bar, yn bar. And if you remember, the variance of small y bar was obtained as capital N minus small n upon capital N small n times s square, and its estimator was obtained here like this. So now if you try to just substitute all those things over here, then the variance of y bar CL will be obtained as expected value of y bar CL minus capital Y bar whole square, and this is something like n minus n upon nn s square, and we are replacing this s square by a new definition, say SB square, where SB square is just like S square, where yi's are replaced by y bar I like this. So this becomes here 1 upon n minus 1 summation I goes from 1 to capital N y bar I minus capital Y bar whole square, right. And this is the. So now we try to find out the estimate of the variance exactly on the same lines. So in the case of simple random sampling, you know the estimate of the variance is obtained as n minus n upon nn s square. Now this s square is going to be replaced by s square based on y1 bar, y2 bar, yn bar, and we defined it as say here as b square like this one, 1 upon n minus 1 summation I goes from 1 to n y bar I minus y bar CL whole square, and this is going to be once again an unbiased estimator of the variance of y bar CL. So you can see here we have found the estimator, its bias, its variance, and estimate of the variance exactly using on the same lines as we did in the case of simple random sampling. Well, now we come to an end to this lecture. So you can see here that after explaining you the basic concepts of cluster sampling, I have established a one-to-one contact, one-to-one comparison between cluster sampling methodology and simple random sampling methodology. And this will help you and me both to find out different types of statistical properties under this cluster sampling. So, I would request you, try to think about it, try to compare both the things, try to compare with SRS and try to derive these expressions yourself. And I will see you in the next lecture once again continuing on the same topic. Till then, goodbye.